Azure Virtual Machines is the Azure Infrastructure as a Service used to deploy persistent VMs with nearly any VM server workload that you want. Azure VMs are image service instances that provide on-demand and scalable computing resources with usage-based pricing. In this video, we will be covering checklist for creating an Azure Virtual Machine, networking, naming the VM, deciding on the location of the VM, determining the size of the VM, the pricing model, selecting an operating system, storage for the VM, and running Linux and Windows virtual machines on Azure. In the end, we will also share details about our free Azure Solution Architect Masterclass, which will not only help you understand basics, but it will also give you an idea of the learning path to follow. It will be helpful, especially when you're preparing for Azure Solution Architect certification, which requires you to clear 2 exams, that are Microsoft Azure Architect Technologies AZ303 and Microsoft Azure Architect Design, that's AZ304. For the certification exam, you should have an understanding of Azure Virtual Machines. Welcome to another episode of Azure video series from K21Academy, where we take you from complete beginner, covering configuring infrastructure, authentication, and securing data solution for the cloud and Azure storage, to all the way identity and security, business continuity strategy, deployment mitigation, integration, and infrastructure strategy, including how to prepare for the AZ303 and AZ304 certification exam. We have taken a clip from one of our certification training program on Azure Solution Architect, that's AZ303. And in this clip, our instructor will talk about Azure Virtual Machines. So, this is a clip taken from a module on Implement VMs for Windows and Linux. Now, let's hear from our expert trainer on the same.
So this is a module 2 where we will talk about implement VMs for Windows and Linux workloads. So this includes dedicated host, scale sets, disk encryption, and high availability. So these are some of the learning objectives. So performing a migration of an on-premise server to Azure requires planning and care. You can move them all at once, or more likely small batches or even individually. Before you create a single VM, you should sit down, sketch out your current infrastructure model, and you have to map it how it can be deployed in the cloud. So these are the different things that we're going to cover. We'll start with running Linux and Windows virtual machines on Azure. Then we'll talk about how to select the virtual machine size, high availability configuration, and Azure dedicated host. And finally, we have scale sets and disk encryption. So let's start with running Linux and Windows virtual machines on Azure. So the checklist required for IaaS virtual machines is start with the network. So that's the reason why the first module we were talking about networking, because that's the first thing that we have to plan, how the networking topology should be or the architecture should be. Then name of the VM, decide the location for the VM, determine the size of the VM, understanding the pricing model, storage for the VM, select an operating system. So we will see each one of this right now. When you set up a virtual network, you specify available address spaces, subnets, and security. If the VNet will be connected to other VNets, you must select address ranges that are not overlapping. So this is something we already discussed in the VNet peering section. This is the range of private IP address that the VMs and services in your network can use. You can use unroutable IP addresses such as 10.0.0.0/8 or 172.16.0.0/12, 192.168.0.0/16, or define your own range. Azure will treat any address range as part of a private VNet address space if it is only reachable within the VNet. If someone else is responsible for your internal network, you should work with that person before selecting that address space to make sure that they are not overlapping, and also let them know that you're going to use it. Segregate the network. So after deciding the virtual network address spaces, you can create one or more subnets for your virtual network. You can do this to break up your network into manageable sections. For example, you might assign 10.1.0.0 to VMs, or 10.2.0.0 to backend services, and 10.3.0.0 to SQL Server VM. So this will help you to manage them. Also, this will give you an understanding. If the SQL is not working, you have to check the NSG on that 10.3.0.0 network. So this is something that will help you a lot in future. Secondly, secure the network. By default, there is no security boundary between subnets, so services in each of the subnets can talk to one another. However, you can set up network security groups which allow you to control the traffic flow to and from the subnets and to and from VMs. NSGs act as software firewalls, applying custom rules to each inbound or outbound request. This can be done at the network interface level or at the subnet level. This allows you to fully control every network request coming in or out of the VM. And also plan each VM deployment. Once you have mapped out your communication and network requirements, you can start thinking about the VMs that you want to create. A good plan is to select a server and take an inventory, like what does the server communicate with, which ports are open, which OS is used, how much disk space is in use, then what kind of data does it use, what sort of memory, what sort of disk. All this information will help you to plan something in Azure. So if you already have an on-premise infrastructure, just see what does the server communicate with, maybe a SQL server in the backend or some other backend services. You have ports 22 and 80 open. The OS is Linux. So this information you can actually use to plan your VM in Azure. So the next thing that we're going to discuss is name of the VM. One piece of information people often don't put much thought into is the name of the VM. The VM name is used as a computer name which is configured as part of the operating system. You can specify a name up to 15 characters on a Windows VM and 64 characters on a Linux VM. This name also defines a manageable Azure resource. It is not trivial to change later. That means that you should choose the names that are meaningful and consistent, so you can easily identify what that VM does. A good convention is to include the parameters that you see on the screen right now. So include environment, like is it a dev, prod, or a QA VM? What is the location? The instance numbers, maybe you have multiple instances that are behind the load balancer or something like that. You have a backup or something like that. So you give proper numbering. You might have a dev in US West 01, then 02. So use proper numbering. Then tell what is the service. Is that an application? Is that MySQL, or is it something else? What is it? An e-commerce application? Is it an e-commerce application? You have to be a little more specific so that the person who is reading that will understand what is the purpose of the VM without connecting to the VM. Then the role, is it a SQL, web, messaging, file server, etc. So for example, if I name my VM as DEV USC Web VM01, it represents the first development web server hosted in US South Central location. So this is how that's a naming convention. That it's a best practice, I would say. It's not a hard and fast rule that you have to name it like this. Your organization might have your own naming convention, so you can follow that. But since if you're new to Azure and start planning your deployment, this is something that you can follow. Perfect. So other thing that we need to decide on the VM creation is like there are other resources that are deployed along with the VM: the storage account, the virtual network, the virtual interface, the security groups, and public internet address. So these things will also have a name similar to that, whatever name that you're giving to the VM. So if I switch back to the portal, and if I go to virtual machines, the name that we gave was VNet2 VM. So if I go and try to find the disk, you can see that the name is actually appended to the disk name. That's VNet2 VM OS disk 1. If I go to networking, if I take a look at my network interface, that's VNet2 VM 902. Then if I go to my public IP address, this one, and it will have a name something similar to that. So basically everything that you see is having the VM name appended to that. So that name is very crucial, because let's say if I see anything that's starting with VNet2 VM, I can easily understand that it's related to my VNet2 VM. So that's the purpose of naming. If you name the VM properly or using any convention that you follow, then you will be able to understand the dependent resources. That's the idea. So let's just go back to the slides. So the next thing we have to do is decide the location of the VM. Azure has data centers all over the world filled with servers and disks. These data centers are grouped into small geographic regions called West US, North Europe, Southeast Asia, etc. This is to provide redundancy and availability. When you create and deploy a virtual machine, you must select a region where you want the resources to be allocated. This places your VMs as close as possible to your users to improve the performance and to meet any legal compliance or tax requirements. Let's say I'm a military organization from Singapore, and the best region I can choose is Southeast Asia. I cannot have my data stored in another country, like for instance US or Norway or West Europe. So choosing the right region has a couple of ideas. One is to provide better performance. The latency will be reduced if you are choosing a region that's closer to you, so that your users can easily access it. Secondly, it's about legal compliance. So let's say, like I said, if it's a military organization, they don't want their data to be stored in some other country. So this is about data residency. Two other things to think about regarding the location choice. First thing, the location can limit your available options. Each region has different hardware available, and some configurations are not available in all regions. Second, there is a price difference between locations. If your workload isn't bound to a specific location, it can be very cost effective to check your required configuration in multiple regions to find the lowest price. Now, how to determine the size of the VM? Once you have the name and location set, you need to decide on the size of your VM. Rather than specify processing power, memory, storage capacity independently, Azure provides different VM sizes that offer variations of these elements in different sizes. Azure provides a wide range of VM options, allowing you to select the approximate mix of compute, memory, and storage for what you want to do. The best way to determine the appropriate VM size is to consider the type of workload your VM needs to run. Based on the workload, you'll be able to choose from a subset of available VM sizes. Alright, so based on the capacity or based on the workloads, the sizes are classified into below types. General purpose, which is designed to have a balanced CPU to memory ratio. It's ideal for testing and development, small to medium databases, and low to medium traffic web servers. Next one is compute optimized. Compute optimized VMs are designed to have a high CPU to memory ratio, suitable for medium traffic web servers, network appliances, batch processors, and application servers. Memory optimized. These are designed to have a high memory to CPU ratio, great for relational database servers, medium to large cache, and in-memory analytics. Storage optimized are designed to have high disk throughput and input-output speed, ideal for VMs running databases. GPU VMs are specialized virtual machines targeted for heavy graphics rendering and video editing. These VMs are ideal options for model training and inferencing with deep learning. High performance compute is the fastest and most powerful CPU virtual machines with optional high throughput network interfaces. So these are some of the options that are available within your in Azure. Just one more thing I would like to add here. What if the size changes? Let's say you start as a small company and you are good with compute optimized and you need high performance right now. So people often come with this question like, what if my size needs change? So Azure allows you to change the VM size when the existing size is no longer meeting your requirements. You can upgrade or downgrade your VM as long as your current hardware configuration is allowed in the new size. This provides a fully agile and elastic approach to the VM management. The VM size can be changed while the VM is running as long as a new size is available in the current hardware cluster the VM is running on. The Azure portal makes this obvious by only showing you the available size choices. The command line tools will report an error if you attempt to resize a VM to an unavailable size. Changing a running VM size will automatically reboot the machine to complete the request. So in case this is a production server, you might need to schedule a maintenance window before you resize it, because the resizing will lead to a reboot of the VM. Perfect. So that's one additional point I wanted to add to the section. Next is the pricing model. So there are two different pricing model available for VMs. One is compute cost and other is the storage cost. Then there is networking cost as well, but that is like the networking cost includes your bandwidth charges, like the amount of egress data, and the charges for the networking, the public IP that you're using if you're using one. So there is a networking charge, but that is usually calculated to the networking part. But these are the main charges that you will see when you run a VM: compute and storage charge. So by compute expenses, we mean that the compute cost, these are priced per hour but billed a per minute basis. For example, you're only charged for 55 minutes of usage if the VM was deployed for 55 minutes. You're not charged for the complete compute capacity if you stop or deallocate the VM, since this releases the hardware. The hourly price varies based on the VM size and the operating system you select. The cost of the VM includes a charge for Windows operating system as well. Linux based instances are cheaper because there is no operating system licensing charge. So if you go to the Azure pricing page and let's say you see a price for a VM as $299 per hour, that's like, if it's a Windows VM, the $299 includes your licensing plus compute cost. And for a same size, you might see the Linux cost coming up as like $200 because there is no license involved in that, right? So the $99 is actually for the license part of the Windows. Second one is storage cost. You are charged separately for storage the VM uses. The status of the VM has no relation to the storage charges that will be incurred. Even if the VM is stopped or deallocated and you are billed for the running VM. So even if you shut down your VM, you'll be charged for the storage. But since you deallocated the cores, you will not be charged for the compute. You'll be able to choose two payment options for compute cost. One is the pay-as-you-go option, and the other is reserved instances, or also known as RIs. Pay-as-you-go. With the pay-as-you-go option, you pay for the compute capacity by the second, which is not a long-term commitment or doesn't include any upfront payments. You are able to increase or decrease your compute capacity on demand, as well as start and stop anytime you want. You prefer this option to run applications with a short-term or unpredictable workloads that cannot be interrupted. For example, if you're doing a quick test or developing an application in a VM, this would be the appropriate option. Coming to reserved virtual machine instances, the RI option is an advanced purchase of a virtual machine for 1 or 3 years in a specified region. The commitment is made upfront, and in return you get up to 72% price savings compared to pay-as-you-go pricing. RIs are flexible and can be easily exchanged or returned for an early termination. Prefer this option if you has to run your VM continuously, or you need a budget predictability. And you can commit to using the VM for at least a year. So the next part is how to select the operating system. Azure provides a variety of OS images that you can install to the VM, including several versions of Windows and flavors of Linux. As mentioned earlier, the choice of OS will influence your hourly compute price, as Azure bundles the cost of OS license into the price. If you're looking for more than just base OS, you can actually search the Azure Marketplace for more sophisticated install images that includes the OS and popular software tools for specific scenarios. For example, if you need a WordPress site, the standard technology stack would consist of a Linux server, Apache web server, a MySQL database, and PHP. Instead of putting up each and everything and configuring each component, you can leverage the marketplace image and install the entire stack at once. Finally, if you can't find suitable OS image, you can create your disk image with what you need, upload it to Azure storage, and use it to create an Azure VM. Keep in mind that Azure only supports 64-bit operating systems. So all virtual machines will have at least two virtual hard disks. The first disk stores the operating system, and the second one is the temporary storage. You can add additional disks to store application data. The maximum number is determined by the VM size. It's common to create one or more data disks, particularly since the OS disk tends to be quite small. Also, separating out data to different VHDs allows you to manage the security, reliability, and performance of the disk independently. The data for each Azure VHD is held in Azure storage as page blobs, which allows Azure to allocate spaces only for the storage you use. It is also how your storage cost is measured. You pay only for the storage that you are consuming. So Azure Storage is Microsoft cloud-based data storage solution. It supports almost any type of data that provides security, redundancy, and scalable access to stored data. So virtual disk can be backed up by either standard or premium storage accounts. Azure Premium Storage leverages the SSDs to enable high performance and low latency for VMs that are intensive workloads. You can use Azure Premium Storage for production workloads, especially that are sensitive to performance variations and that are input-output intensive. For development and testing, standard storage is fine. When you create disk, you will have two options for managing the relationship between the storage account and each VHD. You can either go for unmanaged disk or the managed disk, which is the recommended option. Unmanaged disk, you are responsible for the storage account that are used to hold the VHDs that corresponds to your VM disk. You pay the storage account rates for the amount of space that you use. A single storage account has a fixed rate limit of 20,000 IOPS. This means that a storage account is capable of supporting 40 standard VHDs at full utilization. If you need to scale out with more disks, you will need more storage account, which can get complicated. With the use of managed disks, which is a recommended method, they elegantly solve this complexity by putting the burden of managing the storage accounts onto Azure. So as it says, it's completely managed by Azure. You specify the size of the disk up to 4 TB, and Azure creates and manages both the disk and the storage. You don't have to worry about the storage account limits, which makes managed disk very much easier to scale out. Now let's see what we have next. So running Linux and Windows workloads. So provisioning a virtual machine in Azure requires some additional components besides the VM itself, including network and storage resources. So we already spoke about storage and networking, so we will just see how networking is done. So there will be a public IP address which will be attached to the network interface card, which will be attached to the VM, and this will have NSG. And you can see that there are multiple there is an OS disk, there are 2 data disks which are managed disk. Then there is a temporary storage, that's for storing the temporary data. This is again in a physical SSD on host. And there is a storage account that is for storing the diagnostics logs. One more thing that we have to keep in mind is place the related resources in the same resource group. As you know, a resource group is a logical container that holds Azure related resources. In general, it will help you to manage all of them together and based on their lifetime. So this will be very useful in case of management, cost tracking, and deprovisioning. You can manage, let's say you want to give access to all resources inside a resource group. You can simply give it at the resource group level that will inherit to the underlying resources. Cost tracking, in the user report you can actually sort for the resource group and see what is the cost that has been incurred for this particular resource group. Deprovisioning, let's say you deploy a lot of things for our testing purpose, and deleting the resources one by one is not a good idea. It is time consuming and hectic. So what we can do is we can delete the resource group completely. That would delete the underlying resources as well.
So that was a clip taken from one of the modules of our step-by-step training program on Azure Solution Architect certification, including exams AZ 303 and AZ 304. I would like to invite you for a free masterclass on how to kickstart your journey as Azure Solution Architect, right from learning basics, implementing storage account, virtual networking, and getting certified by using our step-by-step 12-week roadmap to go from complete beginner to a certified Azure Solution Architect. If you're interested, register for a free class by going on to K21Academy.com/AZ30302. I highly recommend you to go through this free class to see what to expect in the exam, learn basics about Azure Solution Architect certification, and to get a demo on deploying Azure Container Instance. So, K21Academy.com/AZ30302. Please click on the subscribe button so you don't miss out on our future videos. I will see you in another episode of Azure video series from K21 Academy. Till then, take care.